Hey guys, Professor Doney back again, and we're continuing our discussion on circular motion. And last time we did a problem where we're swinging an object around on a string. Here we're going to have circular motion. We're actually driving our car into a corner. So there's my car with the stripes, which make it look fast. And we're going at a radius, and there's a left-hand turn we're entering. Okay. I'm going to use mass of the car, 1,000 kilograms, about a ton. It's a smaller size car. Velocity of 30 meters per second, which is, a little over 60 miles an hour. And the radius of the turn is 100 meters. How do we know that? We could look at plans from PennDOT, since we're in Pennsylvania, and how they designed that road and what the curvature is. So it's the radius of that curve. And what we want to find out is how much friction do I need to make the curve, meaning do not slide out of it to actually be able to turn and make it, and then the coefficient of friction there. So, alright, let's go through it. First thing we always want to do is start out with a free body diagram. There's my car. Car has mg down, and since it's resting on the ground, it has F of n up. We sum forces in the y direction, calling positive up. That's a pretty tough color. Let me just switch that out a little bit. Call that positive up, and we find out that the F of n equals mg, which is 1,000 times gravity, which comes out to be 9,800 newtons. Now, essentially, that's the weight of the car in newtons. That's the force of gravity. F of n tells us how much the road has to hold up. Alright, just want to have that there ready because we did the free body. Alright, the next thing, what's the force? We're causing circular motion, so we go to Newton's second law for circular motion. That's going to be mv squared over r. And what we need to do is say, alright, what's the force that causes this mass, the car, to go in a circle at that speed and a circle of that radius? Well, the force here for a car is friction. Friction is pushing when we turn our wheels. Well, we turn our wheels that way to go left. They push against the road, and the road pushes back due to Newton's third law, assuming there's friction or traction, causes us to go in the corner. Alright, so we're going to change it up and call that the force of friction. And what we can do here is start putting some numbers in. We have mass of the car is 1,000. The velocity is 30. We make sure we square that. That's a common mistake. And the radius is 100. We go through that, cross that out as 10, 900. That comes out to be 9,000 newtons of force, friction force, that is needed to make it around that corner. Okay, so that's the answer. The first one up there, we need 9,000 newtons of force. What does that mean? Well, just what we need. And typically people drive at a speed that they know they can make the corner. Now, if you're really pushing it, if you're a race car driver or you're just trying to be a little crazy, you sort of drive on the edge, meaning you're right near that where you're running out of friction. Now, what we're going to talk about is, real quick, is find out how do we find out the coefficient of friction between our tires and the road. Well, if we can go that far, that's how much we need to go that fast around that corner, and that's what we have. We go back to our friction equation, which is the fun equation. Alright, force of friction, mu, or u, and normal. We can put the force of friction 9,000 in there, mu, and then we bring down that 9,800 that we got earlier from our calculation. And if we go through that and take 9,000, we divide it by 9,800, we're going to get about a mu value of 0.92. Now that's a pretty good or strong coefficient of friction. That's going to be fairly new tires on good clean concrete or road surface. So if we're driving on bald tires and there's some gravel or dirt on the road, typically what we have here in the Northeast after winter when there's gravel left, that number certainly is going to drop, meaning there'll be less friction. That's saying how much we need. There'll be less friction, which drops how much friction we have here, which really limits this, how fast we can go around the corner. So we'll look at a problem next that has that change. Hope that helps you out. We'll talk to you soon.